Hi everyone, I'm very excited to be here today. It's my first SREcon, yay! So my name is Ingrid, and you can find me on GitHub and Twitter and different other internet places as Ingrid E. Come talk to me afterwards. I tend to talk about a lot of things, from like culture and tech to security this year. I spoke at a lot of different conferences about how engineers can help with application security and the benefits of building tools with engineering helping different areas in mind. I work for Intercom in the Dublin office. I'm in the production systems team. And there's about 8 of us going around, and we have a booth. We're slowly planning to take over the world. So come find me and chat with us afterwards. So something that I like to do before I start a talk, especially to talk about Intercom, is give you a little bit of statistics over our last week, just to give you more context into the kind of challenges that we're facing and the scale that we're talking about here. Because everyone's kind of going, Intercom's growing, well, exactly how much? So we are a 4 years old Ember front-end, Rails back-end, shared code base, so shared code base for the front-end app and shared code base for the back-end app. And if you look at our stats over the last week for the Rails Intercom app, we had 66 authors that committed on average 390 times to master and more than 500 times across all branches. And that resulted in almost 800 file changes with more than 8,000 additions and almost 15,000 deletions. And that's just in a week. And on top of that, we always say that shipping is at the heartbeat of Intercom. And we ship to production on average more than 100 times a day across the stack. So when you ship as much as we do and build as fast as we do, bad things happen. Bad things happen anyway, but it's a higher chance that they're going to happen to us, considering those statistics. So after we've mitigated the storm and we're at peacetime, we like to run these meetings called like AR meetings, or after action report meetings. And they're part of us trying to understand what happened. So there are versions of somewhat of a blameless postmortem, but in a slightly different format. So we all gather in a room and we focus on answering 3 main questions. What the hell happened? Why did it happen? And more importantly, how can we prevent it from ever happening again? So for the meeting, we write this report, because if you write it, chances are you're not going to forget about it, and it's going to exist, and it's going to annoy you, and then you need to do something about it. So we write this report, and the format of it is something like this. It has a timeline, and we talk about the customer impact. We talked about how we found out about the incident, and how did the team do dealing with that and mitigating with that, and stuff that we learned. And at the end of it, there's this section when we talk about actions. What is it that we are going to do to never run into that problem again? And there's a few things that come up. And 70% of the times, the outcome is more data. And I'm going to explain what I mean by more data in just a second. So let me give you an example. A few weeks ago, we had a batch processing job that failed to do work due to an invalid cron tab. And we wrote an AR report for that, and we sat in a room and talked about it, and lessons learned and whatnot. And the outcome of that was adding 1 test, adding 3 new log lines. And when we say 3 new log lines, the batch process is run on every cluster, which means 3 new log lines on every cluster. And we had to update 1 alarm to make sure that we discovered this problem a little sooner. So I'm going to give you a second to guess how many times the outcome is taking data out rather than adding it in. Any sort of data. Any guesses? Yeah, a few of you did. So complex systems fail in complex ways, and the behavior of adding more data is something quite natural in an attempt to try to control what is happening, or try to attempt to understand what happens. And there's an excellent paper from MIT that I strongly suggest you go read it that addresses exactly that. And for those of you that guessed 0, you're right. There's 0 times the outcome is less data. We never talk about taking data out. We always talk about adding more data, or go and updating data, or change responsibilities, and so on and so forth. And when we say data or information, let's clarify what I mean by that. It's usually falling under these 3 categories of tests, logs, and metrics. in simpler words, some things that provide confidence in whatever it is that you're trying to do. And they're also the pillars of this fancy term that has been circulating a lot on Twitter and on different blog posts lately, which is observability. But let's talk about what the hell is observability anyway, and what is it that we're fighting so hard to achieve it, and why is it that we're adding all this data in an attempt to get to this holy land. So the whole idea behind observability is to gain visibility. It's focusing on what I need to be able to understand my system as a whole rather than as a single isolated entity. So I'm not only just looking at an API, I'm trying to understand what is it that that API connects with and what's going on my system as a whole. And I'm also trying to make sure that I have what I need to be able to understand how that complex system, and not just one part of it, behaves when something unexpected happens. And the bigger, the larger, the more complex the system is, the harder it's going to get for you to be able to answer questions. It's going to get to a point where your questions tend towards the unknown. And Charity Majors, she's the founder of Honeycomb. We use Honeycomb, we love Honeycomb. They wrote this excellent blog post about what is observability. And she made a point that in the end, you're going to not have all the answers. Your dashboards might be all green, everything might look happy, but your customer support is pinging you like crazy saying that your customers are complaining about some sort of error. Why is this happening? I don't know. And that's very common. So the only thing that you can actually do, and you can somewhat predict or attempt to predict, is to add more instrumentation. Try to be some sort of resilient to failures. And also making it fast to deploy and roll back and have confidence in the change that you've just made. And if you translate that in 3 simple words, it will always go back to tests, metrics, and logs. And that's something that we're going to talk about today. And yes, technically, request tracing is something that's another pillar of observability as well, but it kind of falls outside of the scope of this talk. So we're just going to focus on these 3 main things. So let's talk about logs. And every time I talk about logs, there's a little bit of philosophical debate around that. So let's start simple. Let's start by defining the damn thing. So what are logs? I guess you can define a log as a record of an event that happened over a certain amount of time. And it's also a source that knows everything. If you look at it, it's kind of like an oracle. What happened at X time to the service Y? And a lot of people will go like, well, isn't an event a log? Like, what is that? But I guess and that's not wrong. For the purpose of the talk, we're going to talk about logs in the context of like a written record, some sort of written record of an event. But they can be used interchangeably. It's fair. So as we probably all know, just iterating through, there's different sources for our logs. There's application code. There's application middleware, which is something that for those of you that run any sort of Rails service, you're probably familiar with it. There's different servers. There's database replication logs. For example, for MySQL databases, we have those as well. There's load balancer logs, and then if you use any sort of like log streamer, or like Kafka, they do some sort of logs. We run a fleet of workers that rely on Sidekick. They do their own logs. SQS, which is a queue in AWS, they do their own logs, and so on and so forth. So why should I care about logs? They sound cool. Why do I care? Well, they're a very easy way to capture anything that can be of interest from that app. It's very easy to capture behavior. It's very cheap and easy to have a written record of something that you can query at a later time. And it's very easy, in theory, to query that as well. You can use something like grep. We've all used it. It's pretty simple. You have your answer. But the power of logs also comes from looking at it from a historical point of view and being able to do any sort of analysis. We want to be able to determine the behavior of our customers, so your analytics team might be really interested in those records. And also, it's quite useful for security as well. And my colleague Niall talked a little bit about security earlier this morning. And you can actually use logs to detect attacks or for auditing purposes or figure out when someone is trying to do something that they really shouldn't so that you can reach out to them. But at the same time, there's a little bit of like pain in the back of your soul every time you talk about logging, and it's kind of like awkward stares. Yeah, wouldn't that be nice? But it's hard to get. Why the hell is it so hard to get? Well, logs are data, and data comes with all sorts of problems, like what structure should my data be? Should it be like a novel? Should it be JSON? Should it be YAML? Let's not talk about XML. Where should we store that data? Should I store it myself? If you're a startup, you probably don't run your own infrastructure, so whatever it is that you use, we run exclusively on AWS, comes with a cost. Whatever it is that you use to be able to aggregate the data to query it more efficiently, it's going to come with a cost. And there's very few open source solutions, and they're not really that great. For example, I was working for AOL about 2 years ago, and we did run an elk stack, and we actually had a dedicated team of operation engineers looking after that elk stack. By comparison, my team in Intercom is 6 people. We do not want to run elk stack. But also, it's hard to get because it's trying to accommodate multiple use cases. It's trying to support, in our case, customer support to be able to help our customers and support engineering team, operations, have some need of logs as well, and then there's security and analytics and so on and so forth. So you kind of get the idea. It's just one thing that's supposed to solve a lot of problems. And that's how it gets complicated. So I'm going to tell you a little bit of a story now of what logging means for us at Intercom and what have we done over last year and where are we now. So in the beginning, there was something that looked like text. It was basically a collection of different values meaning different things separated by spaces in an attempt to have some sort of format. And then on top of that, because it's great and why not, we were just dumping request parameters. And ironically, those were actually JSON. And it was this weird combination of it's something text, it's something JSON, I don't know. And we also had everything in one production.log file. So that structure was true of everything that was a request, but we also logged like session information and some things for security and some debugging things from our different checks that continued to have this mix of like JSON and text. It was horrible. And we're not running our own logging stack. We use a software as a service for that. So it turns out when you have too much data and no structure and you want to search for a request ID, bad things are going to happen. You're actually not going to get your answers because this system is not performant enough to even handle, first of all, the amount of logs that we have. This is an example, like over 20 minutes, we had 18 million logs for one of our services. So like searching over it, it was just horrible. It was making us unhappy. Customer support was unhappy. No one knew exactly quite what was going on. So we were like, OK, we're going to make it better. We're going to put some structure to this. And this is something that turns out it was very easy for us to do. It was a matter of just changing the formatter. And we were now getting all this beautiful data that is in a JSON structure, and we were quite happy about it. And you were like, yay, problem solved. Well, turns out not really. We still weren't able to answer questions like, how many requests per second is this user making to my stack via this? We had no idea. We were like, what is that? We don't know. Oopsie. So even more horrible, you had to like go back to like aggregate different logs, and then search would become painful again, and things would fail, and we went back to crying. So we started looking into what's an efficient way to add some data that would allow us to answer a wide variety of questions regarding the environment in which this request occurred, and some more information about the request to be able to be more efficient when we're answering questions to our customers or to ourselves. So it turns out something like that is called canonical logging. We're going to talk a little bit about it. So what canonical logging is, or attempts to be, is a quick, easy way to providing more insights into into the environment of your request. And it's kind of like the middle ground between having a metric that just tells you blah straight away, or having to dig through log traces for context. So this is kind of in between, because it will be access to information that you need quite fast without just like giving you a number like metrics would. So usually the way people do it, there's different ways to do canonical logging. They either add like this one big line of fields at the end of the request. So they log that, and then they log the request, and then they're done. And they use it to add more information like the status, the controller, what's the release, what's the host, what's the instance if you don't want to use tags. And we're going to talk a little bit about tags in a second. But it also provides quite an easy way to classify your data. For example, how many 400 requests did this admin make? So we did that. Turns out it's not hard to do it. You just need to focus on what you want out of it, put some requirements down, and then add it. And we managed to capture everything that we needed to answer the questions that we thought were missing at the time in just 9 lines. So we added the admin ID, the cluster, the host, which release, the remote IP service, user agent, which actually is pretty cool because some browsers are horrible, and you've probably known that. I'm not going to name names. But there's also a really good blog post about it. There's going to be a lot of blog posts in this talk from Brander around canonical log lines. So if you want to know more or like go into a little more detail, it's a good way to do that, gain more information. So we were happy at that point. And, but we also learned that we already had a lot of data, right? Like we didn't have to extra work or add like 1 million lines to be able to get the benefits of canonical logging. We just had no story. We had all the information available. We had no way to connect it. And it was very noisy to even understand what was going on or how to make it better until we explicitly sat down and did that. So a lot of data, no story, kind of weird, kind of makes things awkward and hard to improve. So now we were in a place where our debugging was a little bit better, but we were still not quite there performance-wise. So remember we started with this idea that if we add structure, we're going to be able to filter out information that we don't need and potentially be a little more efficient when we query. And by we mean both ourselves, but also our logging providers. So we reached out to them, and we sent them this awesome log line that we were now super proud about, and kind of go like, look at this is awesome, and our tags are awesome. They're the best tags ever. And they came back to us, and they were like, that's an invalid JSON line. That's what it is. And we were like, wait, what? Like, the JSON line's fine. Like, what are you talking about? Like, look how pretty it is. It has a method and a status and a cluster. Like, it's awesome. We did a lot of work for this. And they're like, well, it's either the entire line or it's nothing. We don't read tags. We have no notion of log tagging. We just don't do that. So the obvious reaction was, well, flip table, what is going on? And this is why we can't have nice things. And because it's hard to get nice things, we had to figure out, well, OK, we're not JSON compliant. We should probably fix this, because otherwise we're not going anywhere. We've done this whole work for nothing. And we could work around it and pretty much take requests out, the thing that was JSON, put it in its own file, leave all the other crap data in the main log, and then we could technically search by aggregating those two, and it's going to be somewhat OK. And then if you only need requests, you can only go to that file. But it was a little horrible, and it was a little hacky, and it involved a lot of people having to know where that data is and what that log file means, and it was just, we were not convinced. So the second follow-up was, well, let's just make everything JSON. We have a lot of crap in there that we don't control. That's the output of Rails, sure, but I'm sure we can find a way to work around it. And we could. We used the default Rails logger that has served us well for about 4 years. There was no need to change it up until, well, now. But it was kind of weird and felt kind of hacky, and there would have been a lot of workarounds. If you figured out a good way to like hack into the Rails logger, come find me after. I would love to hear your story. So before going on this or taking on this much work, we were like, well, maybe there's something better that you can just plug on top of that, and it's going to magically fix our problems. So we started to look around to find pretty things. And we did. We found a gem that was looking quite interesting. It's called logging. And it looked super promising. So the first thing that was on my mind, OK, I want to test it and see how easy it is to plug this on top of everything else and have nice, pretty, shiny things. And turns out it's actually quite easy to do so. They provide I'm not going to go into like too many specifics, but they basically allow you to pick a layout. And then whatever it is that you log, you can log in whatever you want to log it. It can be formatted, like the sounds to things that tells you that when Ingrid hears unicorns, she gets excited. Or you can just have a standard error, or you can have any sort of object or any sort of like a debugging message. SREcon, yay. And the output was actually very JSON log heaven, something like that. So the way they format their, the log lines is that they take your message, put it in something that's called message. If you want it formatted, then it's going to keep your object formatting to be able to benefit from being fully JSON. If not, then it's a blob of text, which was a lot in our cases. They're just going to put it there and keep the timestamp, the level, and the name of the logger as other JSON elements. And they're done. So we were quite impressed. It looked pretty clean. It looked easy to use. It meant that we didn't have to go back and fix every single debugging or info message that was just a message. And I was quite happy about that. But we weren't quite convinced until we knew how it would perform. So how do you benchmark a logger? So I wrote a test, and it's pretty simple. It's pretty much start a timer, do the thing, end the timer, what's your result? Do the same for the other logger and compare. And in Rails land, there's this gem called benchmark that I highly suggest you look into. It changed my life. That allows you to run the same test over and over again, and then they will run a comparison for you at the end and generate this really pretty report that tells you, that told us pretty much that the logging was on average about 24.68 faster than the Rails logger. And that was quite interesting. You can actually optimize it more. I had a lot of stuff enabled for this one, like the debug out, like the logging level and whatnot, but the more stuff you take out of it, the more you can optimize it. And that's kind of true of Log4j as well, if there's people that have a Java background, that the more you configure the format of whatever it is that you're logging, that the more performant it's going to be. But if you want to test it, that's kind of the idea of how. So we were quite impressed with it. We haven't gotten as far yet as to ask questions into like, why is this specifically being more performant? This is my life right now, digging through the guts of it and trying to figure out why, because it's really interesting. But it was enough to, for us wanting to see how it would perform in production and enable it on a cluster, leave it running, and see the benefits of it live. Which kind of leaves us to the next takeaway, which is the fact that we realized that we were taking a lot of things for granted for a very long time. And the Rails logger has, again, it served us really well. There was really no pressing need to introduce a new one, other than the fact that we had to constantly work around to make things better, and it was making us slow, and felt like iterating on this was going completely against our culture of like ship to learn, want to go to production fast, and I want what I build to be in the hands of the customers really, really fast. So we realized how big of a change it makes when we actually take time to review the decisions that we've previously made and question everything. So I guess if we were to summarize this logging story before we move on to something else, what is it that's so hard about logging from an engineering and operational point of view? It's hard when you have scattered data that doesn't tell you a story. And because of that, you're not going to be sure what you should even add. And chances are you're going to go and add it rather than start to question it, because that's faster and that's easier. And that's kind of like the normal human behavior to do, right? But also becomes expensive. It becomes time expensive. It becomes cost expensive. It leads to some really weird conversation with your providers. And it's hard to iterate on. And when something is hard to iterate on, no one's going to want to work on it, ever. Fact, which you might now wonder what's wrong with me that I spend so much time on this. But anyway, in the beginning we said that logs are events. So you might think now, well, if logs are events and you did all that work, can we just use metrics and just avoid all this? Like, why would you even? What's wrong with you? And theoretically, logs are events. And metrics are sort of somewhat similar to events. So let's talk about metrics some more and figure out why would you want to have both. So metrics to me answer more simple, more static questions. Like how many requests a second did this API have at peak time? And it provides facts as answers over context. It won't tell you exactly, I don't know, how many requests did admin X did on stack Y. It's just going to tell you there are X requests. Go do with that whatever it is that you want to do with that. And because of how factual it is over context, it's very easy to use it for something like alarms, which I'm sure we're all familiar with. So why do you care about metrics, and why should they be considered? Metrics also provide better data aggregation over time, because they tend to, like, the volume of data tends to not change with the volume of the request, right? You're not gonna, if one of the API takes, I don't know, 2 million requests a second, chances are, if you're logging every request like we are, we're going to have to log 2 million requests a second. For a metric, it's just going to increment that particular counter, so it's just going to tell you, well, yeah, right now it's 2 million. Go do something with that information. And it's a great way to measure the impact of something over like the context and the environment, and analyzing what happened. And it also makes for great historical trends for that particular reason, and it makes it easier to visualize the data. Have you tried visualizing text? It's a little bit horrible. And sure, you can get stats out of logs, but statistically and realistically, metrics are a little bit faster. And something that really confused me when I had to look at metrics or create metrics is the different metric types. So we use Datadog as our main metric provider. And this is like an attempt to shed some light over the different types of metrics and why they matter and why should they be used for different purposes. So there's something called gauges, and I'm Romanian, I might pronounce this weird, come talk to me if I am. A metric that's a variation of a particular value over time. For example, the number of active users on a website at a given time. There's also counters, which is pretty straightforward. How many times something happens per second, like, for example, page views or number of requests. There's also timers. So timers are quite interesting because they allow you to measure the performance of that particular block of code. So say I have a service that imports users from a CSV file. Ideally, I kind of want to know how that performs over time, given the amount of data that particular user triggered the import for. So that's when a timer might come in handy, and we're using those in our app in a bunch of places. And you also have histograms, which is more like a statistical distribution. So whenever you're looking at your service from trying to understand what's the minimum and what's the low and what's the average, a histogram is something that could be quite useful. And the metric is only efficient if you know what you want to do with it, and if you know in what category does it fall into. So if we look at this graph, for example, we're trying to calculate the average of updates per segment membership. This wouldn't really make sense as, it wouldn't be as descriptive to like figure out the trend and the number of updates if we were to, for example, use a counter. It would be a completely different information. It would tell us a completely different story. So choosing the right metric type can help you visualize the data better and answer the questions that you really want to answer a little bit better. So what do you capture? We're here to talk about noise and why noise is bad. So what do you capture? Do you just capture everything, which is a very popular myth? It's very cheap, you should do it, yay. Well, usually metrics are used in like 3 different, or like the most use cases are engineering, operations, and some sort of analytics. Our analytics team cares about metrics as well, and they ask us to log different metrics. And we're going to talk about that in a second. So from an operational point of view, there's this image that was quite popular on Twitter, and it's coming from Tom Wilkie, which I think is at Google. And the reason why I like it is because it's very easy to remember. He's suggesting this red use, or like use red approach to metrics, to figuring out what metrics should you capture. So red is for request rate, E is for error rate, D is for the duration of requests. And he's saying that you should use them for like 95, they're going to cover about 95% of your monitoring and alerting. And then the use metrics are something like utilization, so like CPU, number of requests, blah, blah, blah. Saturation, which means how many requests was I actually unable to process, because that's a problem, you might want to know about that. And then different types of error metrics. And it's a pretty interesting kind of catchy way of remembering it. There's also a Datadog. They wrote this extensive article about it. If you're curious, go read it. Or, as my colleague Niall, that is on my team, would say, am I willing to get out of bed for this? And that's kind of more of like a more sane approach whenever I'm trying to like capture any sort of metric. Do I really want this to wake me up? Do I really care that much? And it's a great way to clear out some of the noise. On the other side, there's engineering and there's analytics. And things get a little more complicated because they're a little more put in context, right? So engineering usually wants to answer a different question, like, is this useful? I just want to see what this looks like. I don't know what it looks like. You're talking about requests. I want to see it. And how much of a problem is something over time? And speaking of that, when I started in Intercom, I was part of a product team. I built one of our main products now, which is called Educate. And with Educate, we would allow our customers to create content for their customers. So with content, combined with a lot of bad, evil people in the world, comes potential threats. And we wanted to make sure that we are able to detect malicious content into our articles. So for each article, whenever it gets saved, we would scan it, and we would increment the metric that we have detected that malicious URL. And then we'll also log an event because we wanted to be able to visualize that. And we didn't quite know how big of a deal is going to be, or how important it's going to be, or if this is actually something that we should care about more. So we've decided to just log an event to be able to visualize it and see the trend over time rather than have to go through logging. It was just a better idea at the time. And something that we also did in an attempt to figure out what was going on is to create a Slack notification or a Slack alert. So initially, it was this thing where we got quite excited that that particular job caught something, so we would send a notification for every single URL, for every single article, for every single company. So it generated a lot of noise, and it was realistically, no one looks at Slack notifications, so it's this shout out into void that annoyed people, and no one really wanted to care, and it was horrible, and we didn't want to look at it anymore. And the other downside of, I want to create something just so I don't forget about it, is dashboards. We are now proud owners of something around 900 dashboards. By comparison, by comparison, there's what, 120, 140 of us, I think, across all our offices. So we have definitely way, way more dashboards than people. And the reason why that happens is because, and the reason why that is so painful and it has such a big impact in our happiness levels is because when you just have a notification or you have a dashboard, you don't quite know how you should feel, right? Like if you look at the first graph, which is the CPU utilization, I don't quite know how I should feel when I look at this. Is that it's 30% bad? Should it be lower? Does that mean it increased? I don't know. This is kind of like a silly example. Imagine it's something like 90, but like anyway, like I'm confused. Why do you exist? If you look on the one on the bottom though, it clearly has a line, so I do care if the latency goes that high, and I'm like super low right now, so I can pretty much see it, make a decision straight away. It's a no-brainer, and just move on. It makes for much faster reasoning, I guess, is the word that I was looking for. And also, because I don't quite know how I feel, I don't quite know what to do with it as well. Should I like ignore it? Yay? Should I like look into this because it's not working quite right? Should I wake someone up now because things are on fire? And the answer to that is, well, I don't know unless I know what threshold of that thing is. And numbers are great. Numbers are great for answering very fast questions, but they're not very chatty. They don't give you a lot of context, and logging might not be as fast as metrics. So how do you make sense of that? How do you make something tell you something? And the answer is, well, you should have thresholds if possible. And they come in handy for two things. One, you look at a dashboard and it exists, and it's going to make way more sense from like a visual point of view. And two, you get to create all those fancy alarms that now wake up, if they do wake up people in the middle of the night, fingers crossed they won't. At least they're doing it for the right reasons, and people know why. So the danger of monitoring in general, if you look at monitoring, or like if you look at metrics, you look at monitoring and alarms, right? Is that unless something is actionable or tells you something, it can create a lot of confusions when you look at them. You don't quite know what to do. And at the same time, you can also get into a situation where if it pages you, it might page you for the wrong reasons, where you might not quite know why, or it might page you for something that isn't even broken. It was just an invalid threshold. And ideally, thresholds should come out of load testing. And my colleague John Dooney is going to talk about load testing tomorrow. So do go watch his talk if you want to know more about setting thresholds and performance tests. So again, if you remember like the beginning of my talk, I feel like I've talked for a very long time. There were also tests there. And I guess with metrics and logging and observability, it is kind of obvious why they're there, but you're probably wondering, why the hell are tests there? What are you trying to talk about? So tests are here because they're putting things into context, and they're putting the importance of monitoring in general into context. So in general, when you test something, you're kind of doing your best effort. Realistically, you cannot test everything. But when you look at your service from a risk approach, I don't have time to test everything. I'm going to test only the risky stuff. It's going to tell you what you should even monitor for and what you should care for as well, and areas that you can potentially want to alert or wake up someone in the middle of the night for. But tests are also foundations for load testing, and I kind of touched based on that a little bit before. So that's why they're here. The problem with tests as well is that they can also make or kind of break your workflow. So I mentioned in the beginning that we ship to production on average 100 times a day. And we're also the second largest Amber app in the world at the moment. I think LinkedIn are first. And we care a lot about clean code, and we care a lot about standards, specifically because both our main apps, or like parts of our main app, are a shared code base between multiple teams. So we want to make sure that we don't promote a pattern in which when someone joins the team, and it's a usual thing for us to switch teams or go on tour on different teams if we want to, for someone to be confused and see like version A of something and version B of something and kind of try to cross them and spend a lot of time to decide into what is it that is the correct approach between those two. So I'm going to tell you a little bit of a story. So when I joined and I was working on Educate, I also did like a part of the front-end work. So we had this thing called CI tests that was pretty much a bash script, part of our Ember.js JavaScript code base. And it was trying to do all the things. It was about 200-something lines of testing JavaScript, of testing CSS, and they were done in an awesome way with system calls and grep and regular expressions, and there was one regular expression per each test because they were all doing specific things. And it was horrible, and it was cutting down readability, and regular expressions are a little bit of black magic, and it's just hard. But the real problem with them was that you will only know of it whenever your tests ended up in some sort of continuous integration, continuous testing environment. Or if you knew about it, which when you just joined or when you've switched teams or if you've never worked on that area before, chances are you're not going to know of it. So the feedback was quite slow. I had to write some code, commit my changes, push to GitHub, be very happy that my unit test passed. And then this test would display this critical, cryptical, weird, red, scary error that there can't be more than X uses of something, and I've done something, and I don't really understand what I'm supposed to even correct. So it's very confusing, very hard to action without going and doing a lot of research. And the outcome of that, and like if you think of it, development time is really, really important. And there's no point of having like any sort of instrumentation that is awesome, and there's no even talking about resilience or deploying with confidence unless your tests are as good and are able to keep up with that. But not getting feedback on time means that you're going to be eventually slower fixing your tests, which is going to slow down your engineering time. You're going to run the thing more times. You're going to drive yourself a little crazy. You're going to get frustrated. You're going to go, what is this? And eventually you're going to burn out. That's how burnout happens. So we looked into, okay, Bash is kind of horrible. It definitely doesn't fit into this code base. What other alternative is there? And turns out the technology, like the JavaScript event and the tools around JavaScript, caught up with a lot of the problems that we had, like real-time and real-time feedback. And linters were now incredibly accessible for us to use. So there was no reason to hard code this or do the work of statically analyzing the code, which is really a job of a linter, the same way we did like 4 years ago when we started. So we wrote a thing that relies on linters, that whenever you update a file and the file compiles, it will display an error telling you you've done something. And the error is customizable, so you can actually use it to onboard engineers or give engineers context into what is it that you're doing rather than just blocking behavior. And linters are great. They're also notoriously slow. And something that we found out that was quite interesting that we've never considered is that linters do caching too. And they rely on caching a lot for performance because disk is slow and they have to deal with files. So tip, if you think that whatever checks that you have with your linters, we have about 50 of them, are slow and you're not happy, look into caching. So if you look at it, the problem with that wasn't necessarily that we're doing something wrong, we're testing the wrong things, or we had too many tests, but it was more this idea of a snowflake behavior. It was Bash, it didn't belong in the code base, it wasn't really the job of a test inside Ember to handle everything that we were trying to do. And it was very focused on stopping bad behavior, but no one actually took the time for a while to ask themselves, what's the impact of that for engineering? And blocking something without providing context makes a lot of people very, very sad. So Snowflake, the reason why this is here is because it's very easy to have any sort of Snowflake behavior in your code base that is going to essentially just tear down all the other good, awesome stuff that you've built. So if we go back to what we said initially in this talk, 70% of cases, 70% of actions after any sort of incident is adding more data. And the natural response is to add more data. And raw data is just noise. So adding purpose to the data turns it into information. Thank you very much. It was awesome to be with you guys here today. That kind of concludes my talk and the message that I want to leave you with. Wow, there's a lot of people in the room. I will try and take your questions private, just because we're after lunch and probably it would be good for us to move in a little bit. So come find me. I would love to talk to you. If you have thoughts, message me. Find me at the Intercom booth. Thanks. Have a nice day.